Good morning, Hughes Hearth Heroes. Today is February 28th, 2014. This is my flip attempt number 3. I'm going to focus on radical functions this morning with working with rationalizing the denominator. Again, my name is Mr. Hearth. And here we go. So this is a bit I pulled from online. If you just look for conjugates, a conjugate doesn't necessarily mean to apply for radicals. It just means change the sign in the middle of two terms. Two terms, right? So when it says two terms, that means there's a binomial. And so here are some examples. You can pause and look at this a little bit more because I don't want to really spend too much time on this. I'm going to do the problem on the next slide. But the expressions that are given and the conjugates, you'll notice that nothing changes letters, exponents. All that changes is signs, are the signs. That's all that changes are the signs. So pluses become minuses and minuses become pluses. Examples of use are that they become very useful because when you multiply something, you get squares like this. Squares are very useful because they can cancel radicals. So here's our next example for this morning. Our first example, and this is our problem. Okay, so we are going to simplify this radical by using conjugates. So what is the conjugate for this example? Well, if it's a square root and a square root, there's a plus. I'm seeing these stay the same, but I get a minus. I have a phone call, so I will be right back. And we are back. And we are back. Thank you for joining me again. So let's figure out the conjugate. The conjugate of this is going to be a square root and a square root, a radical and a radical, and it's going to be that 13 and 11, but instead of a plus, it's going to be minus. Now, since we're multiplying, we don't want to change this. We want to multiply by the same thing on top and bottom. So that's square root of 13 against minus square root of 11. So we can do the top. Now, for this sake, and this time, I will show you a little bit more about like why this cancels. Again, this is if you do FOIL with this. So maybe if I just even do a box over here to the side, because that's how we would FOIL sometimes in our class. We would have radical 13 minus radical 11, and then a radical 13 and a positive radical 11. And when you do the radicals, they just cancel. So radical 13 is a 13. Radical 11 is an 11. But that's a minus because positive and negative. And you notice when you get these, you'll get a radical 13 times 11. And this one's 11 times a 13. But this one's positive and this one's negative. But they're the same number, so these are always going to cancel. And so that's why we can just go ahead and write down the radicals without the radicals. And then you can do it. But on top, we still have a little bit of math to do. We have to distribute the 14 to both terms on top, so we're going to get 14 radical 13, and then it's a minus, so minus 14 radical 11. So on the top right now, I can't simplify anything. This is 14 radical 13 minus 14 radical 11. So 14 radical 13 minus 14 radical 11. But on the bottom, I can do that. 13 minus 11 is 2. And at this point, it gets a little interesting, and this may be a little additional discussion, but if we just look at the radicals, they're not like terms. But then if I look at the coefficients, you'll notice that the 14 and the 14 and the 2 can all be divided by 2. And this can be done for one simple reason. When you have a fraction like this and you have two terms on top, you can basically kind of split it down the middle. Okay, and if you split it down the middle, you're going to get a 14 radical 13 over 2 minus a 14 radical 11 over 2. And then you can really see that the 14 and 2 and the 14 and 2 will cancel. And so you're going to wind up with the final answer of 7 radical 13 minus 7 radical 11. And this will be our solution for today's flip journey. Hope you had a good time. Hope you are remembering to answer questions and provide questions. And if you want to try this, a good question, let's go with making up one. So let's do a little bit more. Let's go a little bit deeper. Let's keep the numbers smaller. Let's do 2 radical 5 over radical 3 plus radical 2. So if you're up for the challenge again, here is an assignment problem that you can try within your notes that we will go over at a later time. All right, so again, questions, notes, and thoughts. And we'll talk about this next week sometime, okay? Thanks, and have a good day.